Welcome to the Being an Engineer podcast. Our guest today is Russ Aldridge. Russ is a mechanical engineer and CEO at Sisu, that's S-I-S-U, where they design and build machines for people who want to change the world. So Russ, thank you for being with us and welcome to the show.
Thanks, Aaron. Glad to be here.
All right, let's start off with the name Sisu of your company. Where did that name come from? What does it mean?
Yeah, we get that question a lot. So when we were trying to come up with a business name, anyone who's ever done that knows that that is a horrible, horrible thing to put yourself through. And we were trying to find a name that wasn't already taken. We were actually watching the British car program Top Gear, where the guy, if you're familiar with that program, it's a car program. The guys go to Finland to find out why the Finns are such great racing drivers. They have more F1 and rally car champions per capita than anywhere else. And they tell them, they said, well, it's really about Sisu. They said Sisu is a Finnish word. There's not a direct translation in English, but it really means kind of having the guts to go for it, to brake late going into a turn, and just kind of having that courage and that long-term perseverance. So my business partner and I were about to quit our jobs. We've got a mortgage and kids and all that stuff. And we thought, yes, we're going to need Sisu for sure. So that's where it comes from.
Very cool. So you said, was it Swedish?
Finnish. Yep,
Finnish. Okay. And let's not neglect Marc here. You have a co-founder, Marc Christenson. How did the two of you collectively decide that let's quit our job and start this brand new company?
Yeah, so I met Marc Christenson in an interview room at Brigham Young University. I was graduating, and he was there with representing National Instruments, which is a tech company in Austin, Texas. And he interviewed me. It's the first time I met him. He decided for some reason to hire me. So I came down to National Instruments and we became very good friends. We hung out all the time. We commuted to work together. We talked about business ideas all the time. Both were entrepreneurial minded. And just over time, we thought, you know what, let's start a robotics company. Marc was doing a lot of the support for some of the automation equipment at National Instruments. And people would say, I love this stuff, but who's the company that can put it all together for me and make it actually work? And he would say, well, it's kind of new stuff. There's not really a company that does that. And so that's the gap that we saw. That was the niche that we left to fill. And so about almost 3 years after being at NI, we walked in and quit our jobs and started in the garage. So that's how it started.
What were some of these things that you were putting together at NI and there was no, I guess, integrator might be a good word for it, to put it all together?
Yeah, like a systems integrator. So National Instruments was coming out with these different ways of controlling kind of high-end motors. And so NI is a test and measurement company. So they do a lot with vision, with high-speed analog. And so they thought, you know what, people are going to be using high-speed analog and vision in robotics, and we might as well come out with some motors, some servo motors and controllers, automation controllers, so that NI can just sell that whole platform to people. And so people would want to put together a machine to do, all kinds of things. A lot of the national labs where they're measuring stuff, but they're also moving things around. They wanted those kind of products. And so they'd say, we can handle the data side of it, but somebody needs to help us put together the motors and the automation and the robotics part of it.
Got it. So you started your career at NI. What was your role there? Like, what was the day-to-day like for you as a new engineer at NI?
Great question. So I was a hardware engineer and mostly in charge of electronics packaging and thermal analysis. Love NI. NI is a fantastic company. Have nothing but good to say about NI. But I was a little bit bored, to be honest with you, even though I love my job, love the people I worked with. Just wanted to do, really excited actually about using the products that NI makes instead of designing them. So anyway, a lot of thermal analysis, but it really gave me a good handle on some of the basics. Somebody gave me some advice early on I wanted to start a company right out of college, and they said, yeah, don't do that. And I'm really glad I didn't, because I was able to learn a lot of CAD, a lot of analysis, get relationships with different people, understand more how the business world works. So that's what I did at NI.
You mentioned that you've always been entrepreneurial. Was your family entrepreneurial? How did you get that bug?
I remember my dad when I was a kid. I don't remember how old I was. Probably 10 or 12. He dressed me up in a shirt and tie and took me around with him to his sales visits. And looking back, I can't believe he did that now. But I remember just, entrepreneurial is one word, but also inventive. Just wanted to come up with lots of different inventions. And so when we were thinking about this, and I asked my wife, who's from Utah, we moved from Utah, didn't know a single person, and asked her, what do you think? Are you okay with this if we start a company? And she said, well, what's the worst that could happen? And I said, well, we could lose everything and have to move back to Utah. And she said, well, we don't have anything, and I'd love to move back to Utah, so go ahead. And so we did.
Challenge accepted.
Challenge accepted. And 10 years later, I think she was hoping it would fail so we could move back and see her friends, but to her chagrin, it hasn't failed yet. It's been 10 years on this past Sunday. So
that's maybe one of the best company start stories that I've heard. We don't have anything, and I'd love to move back to Utah, so go for it. Yeah. That's terrific. Okay, I need to back up a second here. Your dad dressed you up in a shirt and tie and took you with him to sales meetings. What was that all about? Why did he take you dressed up like a junior executive?
My dad he's a brilliant engineer. He's a smart guy. He's not a sales guy. I think he, one of two things, either he didn't feel comfortable just going by himself, or honestly, he was using me for the kid factor. So.
Either way, brilliant. Okay.
Yeah, maybe.
What were you like when you were a kid? Were you always into like really mechanical things? Were you building Legos and robots and stuff like that?
There wasn't a whole lot of, robots back then. It sounds like the dark ages, but I don't remember that much robotics. But I love the mechanical part of it. Technic Legos was the big one for me. I built transmissions out of Technic Legos. I remember building a differential and being really frustrated because I didn't have a gear with the center as a through shaft. It was splined, and I wanted to drill that out. And I remember this internal dilemma of, can I modify my Legos so I can make a differential that actually works? So a lot of that. I remember my favorite thing to read was a car manual, an auto repair manual from 1968. Just thumbing through it, I was just fascinated by the parts, how things fit together. My dad, he really nourished that in me. My 11th birthday, he bought me a 1971 Ford F100 pickup. He found it for $100. Actually, I think it was $150. And I had been saving for a car, so I gave him $100. He gave me 50 for my birthday. And then we worked on that together all growing up to learn about mechanical things.
Wow, amazing. You probably didn't learn anything, though, working on a car like that for several years.
Well, the good thing about old cars, and especially Fords, is the amount of times they break provides so much opportunity. At least that's what he would say. He was a Chevy guy, so he would always tell me he bought a Ford because he knew it would break down all the time. We'd get to spend time together.
Yeah, that's fantastic. I've talked to a lot of engineers and engineering managers, and almost universally, when I ask them, how do you decide whether to hire someone or not? How do you decide whether an engineer is going to be good? They tell me if they know how to work with their hands, if they've built things, and often cars come up, if they have a background like building cars and fixing cars, that immediately is a great signal to me that this person is going to be a talented and valuable engineer.
Yeah, absolutely. That's one of the questions we ask all the time is, what do you do when you don't have to do anything? Find out what people do in their spare time. And maybe one of the best answers we got to that was someone who said, I built a 3D printer at home. That was before 3D printers were as mainstream as they are now. I said, I built a 3D printer and I make parts at home. And my wife's computer failed, and so I pulled the motherboard out and put it in her oven and reflowed the solder and got it working again. And so he went from one of our very first hires to now he leads our hardware engineering team at Sisu.
Now he gets to get paid for all those things he loves doing anyway.
That's right.
Great. Okay, so Russ, the Sisu website, which is what is it? Just sisu.com, is that right?
Sisu.us.
.us, okay.
Yeah. If you go to sisu.com, you're going to get vitamins, which are good for you. But if you want robots, go to sisu.us.
Sisu.us. All right. So it's pretty basic right now. I think it's changed recently. There's kind of just one page, but if you scroll down towards the bottom, there are all these really cool case studies that I found. And honestly, as I was going through the case studies, I got really excited to talk to you because there's some of the coolest projects that I've seen an engineering company do. You know, there are product companies out there that you're building, I don't know, a wrench or a hammer, or you're building some part, and they're not all that inspiring or interesting all the time, but you guys have done some legitimately cool stuff. So I want to talk a little bit about some of those projects. Maybe the first one to start with is the OmniSharp machine. Can you tell us a little bit about that?
Yeah, for sure. So, I mean, all of these start with a problem, right? So the problem is you've got these meat packing facilities. The ones in North Texas are a good example. Most people don't realize the scale of these, but if you think of how many burgers are eaten across America, you start to realize the supply chain that's necessary. So up in North Texas, you'll find a facility that slaughters about 6,000 head of cattle per day. And there's, in the panhandle of Texas, there's probably 8 of those or more. And it's just unbelievable. And so they're sharpening in there, the knives that they're sharpening, it's about 3,000 of them per day. And it's, they used to sharpen them with a guy pedaling a stone and spins the stone around and they put the knife on it. And in the last 2,000 years, the only thing that's really changed about that is they put a motor on the stone, and it's still just done by hand. So the challenge was, and knives have been sharpened by robots for a long time, but they're new knives, brand new knives, same shape every time. The challenge was, can you make a machine that I can put any knife in, long, short, curved, straight, old, new, bent, broken, whatever, and it will be able to sharpen it. And so we had to develop a system that would basically pick up the knife, create a 3D model of the knife, learn everything about it, create a sharpening profile, and even that wasn't enough, because then you have to have a 6-axis force torque sensor on the robot so the robot can actually feel its way as it sharpens and sharpen it exactly the way that a master knife sharpener would sharpen each and every knife. And so that's been a really fun project to work on over the past few years. We've shipped a couple of them. They're having great success. And we're building a bunch more to send out there. It's really going to be an industry game changer.
It's not like a standard profile is entered into the machine and the robot just runs through this, same trajectory every time. The robot's actually sensing and detecting differences in the knife designs, the blade shapes, and accommodating for that in real time as the knives are being sharpened. Is that right?
Yeah, exactly. So I'll nerd it up here and go to my sketchbook real quick. So if I draw a knife profile, you can see like this. Here's my blade. So you need to understand, what this shape is. But if you take the cross section of a knife, it kind of looks like, I'll exaggerate it here, but if you look at the cross section of it, there we go. You've actually got this big grind, which is what you see on your kitchen knives at home, that kind of dull part that's, big grind on the knife. That's called the hollow grind. And what it does is it thins out the knife. So at the bottom, you can put this little V on here, and that's what really does your cutting. So we not only have to figure out what the profile this way looks like, we also need to build a model of what this looks like and decide, has this knife been worn down too much? Do we need to hollow grind it again before we put another V on it? So it turns into a pretty complex algorithm.
I get it. Unfortunately, we're not going to have any video on the podcast. So for all you listeners out there, you just missed out on not just a great engineering explanation, but a truly inspiring artistic session as well. Yeah.
Sorry, I didn't realize we weren't on video too.
No worries.
Well, that's good. They don't have to look at me. I'll spare your viewers the pain.
All right. So when Sisu first was started, were you doing a lot with robotic arms, or was that, several years down the road?
No, actually, when we first started, it was more with just motors and slides, just actuators, mostly linear actuators. And we kind of came out of it by necessity, where we were spending so much time just building a custom machine with all the, integrating the motors and all this other stuff that, eventually we were kind of like, there's got to be a better way. And I don't know how we went for so long without really getting into the robot arm. But once we found it, we realized we don't have to waste all this time and charge our customers all this money to come up with a mechanical solution. That part already exists. We can basically turn these problems into a software problem. And that's kind of what happened with the knife machine. We built a custom machine with, 6 or 8 motors, and it just wasn't necessary. And so when we revamped that, we said, let's throw a robot arm in there and teach the robot arm how to feel its way through this problem.
How long did it take your team to climb that learning curve for working with robots? Was it pretty quick, or is it a pretty steep learning curve?
We've got quite a few software guys that are pretty sharp. That's not me. I'm not a software guy, but it wasn't bad. Honestly, these robots are so powerful because they have to make them so that they can do everything. They can sharpen knives and load a machine and, just everything you can imagine, paint a car, weld stuff. And so the result is that the user interface, while powerful, is pretty difficult to use. And so our guys figured it out pretty quick. They pretty quickly mastered the robot arms, especially from KUKA. That was kind of where we started. But they also kind of got to, and we can talk more about this later, but kind of got to the point where they said, man, just for everyday stuff, it just doesn't need to be this hard. So for a software engineer, it's not bad. But for, just a dumb mechanical guy like me to pick these up and try to use them, the industry is doing better, but it's still kind of difficult. There is definitely a curve there for programming some of the robots, and some brands are better than others.
Yeah. This is a great segue into the next question. You kind of hinted at it, but learning a robot can be a little bit challenging. It's getting better, but there's a pretty cool innovation that Sisu has developed to make that process much, much simpler for someone that, especially for someone that just doesn't know how to control a robot. Can you talk about that a little bit?
Yeah, for sure. So like I said, when we got our first robots, we pulled them out of the box, and it was just unbelievable to us how long it took to even get these up and running and moving, and then let alone program them to do something very simple. And we said this was a few years ago. I think it was, maybe 2017. We said, man, it just shouldn't be this hard in 2017 to do this. And so we sat down, we said, what would be the best way to move a robot and program a robot? And we came up with all kinds of ideas. We just war roomed it for hours. And we came up with a few ideas. And one of them was, we actually had a little plastic model of a robot arm. And we said, what if we just put encoders on this guy? And then you could just sit back and move this robot, and the big robot will know what you want it to do, and it'll just move there. You don't have to worry about X, Y, Z and ABC and moving axis 1 and then axis 2. And so we called it Voodoo, because it was like a voodoo doll. You move the little doll and the big thing moves. But we came up with we said, well, that's fine, but if you're trying to do very small, precise movements, then that's difficult. And so we came up with basically a game controller you hold in your hand, and when you squeeze the trigger, it's like you're reaching out and grabbing the end of that robot arm. And as you move your hand up and down, left and right, the end of that robot arm follows you. But also as you articulate your hand, as you move it around in a circle or angle it left or right, the end of that arm also follows you. And so it's pretty magical looking, honestly, to just sit back, and you can have a huge robot that, is capable of lifting hundreds of pounds, and it's got some big payload on the end, and you just squeeze that trigger and move your hand around it. It just kind of floats that object exactly as you're moving your hand. We thought that would be a great way to do it. Let's put some controls on it to make it so you can do very fine motions. And then let's apply that to some. This is kind of interesting, maybe down the road a little bit, but what we hoped, this was a lesson that we learned the expensive way. We hoped that users would look at that and say, wow, I can take that and I can program a robot to do whatever. I can have it do painting and welding and whatever, and I'll figure that out and make it work. That didn't happen. What we learned was that we had to say, the user does not care necessarily about being able to easily move it. They do, but they don't know that they do. What they care about is getting their part welded. And so we need to take this robot and put it on a base that a welder can move around their shop and put a welder on the end of it. So when they open the box, it's already got it hooked up. And so that all they have to do is wheel it up to their bench, plug it in, and then when they squeeze the trigger, all this cool motion happens, which they just think, well, of course it should be that way, and off they go and weld. And so the same thing with a camera robot. We hope people would figure it out. They didn't. But once we put a camera on the end and all the lens controls and put it on a base that they could move around and painted the whole thing black and put controls on the software to change focus as the robot moved, then they go, okay, now I get it. So we really had to not just stop it, wow, this is a cool engineering toy. We really had to take that all the way to how does this solve the customer's problem.
Have you ever wasted weeks fixing a design issue that could have been caught early, or struggled to find real, practical answers to manufacturing or tolerance stack-up problems? PDX 2025 is not your typical trade show. It's a hands-on engineering training event built for problem solving. Learn advanced CAD surface modeling, GD&T, DFM, adhesives and bonding techniques, metrology, and much, much more directly from subject matter experts in the industry. Bring your toughest engineering challenges, get live expert advice, and see real-world solutions in action. PDX 2025 is happening October 21st and 22nd in Phoenix, Arizona. Walk away with new skills that make you more valuable, help you grow your career faster, and even increase your earning potential. Spots are limited. Sign up now at The Wave. And I've seen videos of this system in use, and it really is magical. I mean, it's so intuitive. You're just using the natural motion of your own arm holding this controller to program a robot, and it's like nothing I've ever seen before. And when you mentioned the camera, that's cinematography, right? You're working with, one segment anyway is you've been selling to cinematographers.
Yeah, exactly. So either for making movies, but more often it's for making commercials. So the idea is that a couple of things. One, stuff that they used to do, we had one of the cinematographers tell us this. He said, there was this job, it used to take us 3 or 4 days. He said, I can do that job in an afternoon now. He was doing a shot where he flipped Oreos into milk, something you'd think would be pretty simple, but it's amazingly complex to get that cookie to hit the milk just right and the milk to splash just right and to capture it with the camera exactly the right way. It's very complicated. He said, I'd do that before, and after a day or two of filming, I'd have 1 or 2 takes that maybe I could use. He said, after a day or two of filming with the robot, I had 30 takes that I could use, and I just had to pick my favorite one.
Man, that's incredible.
Yeah, so it's just making it a lot, things they already did, they can do a lot faster, and stuff they couldn't do in the past, now they can do.
You design a control interface for industrial robot, and the natural expectation is that robot's going to be used in industrial applications. It's going to be used to weld cars together. It's going to be used to process some kind of assembly line. How did you think outside of the box and come to this insight that, hey, we can use this to mount a camera at the end of the arm and use it for the moving commercial industry?
Well, I wish I could take credit for this, but this is an example of, if you just keep your eyes open and watch stuff, you might learn something. We had a cinematographer come over to do a video of the robot to try to sell it for industrial purposes. And he said, you know what, guys, you really should put a camera on the end of that robot arm. And we said, no, that's not a thing. And that's what he did. He started laughing. He said, no, that's most definitely a thing. And he said, and we are not engineers. We are not robot people. We're artists. And he said, I can just move this camera wherever I want, and I can just I can get my creative vision down, and I'm not fighting the robot. You can teach me how to use this thing in 20 minutes. And so he kind of cued us onto that. And so we posted we just did an Instagram post just to see, and we sold 4 of them from the Instagram post. We thought, okay,
wow.
this is a thing. This
is a thing. Yeah.
Let's go after this one.
Yeah. So what ended up being that cinematographer's consulting fee on that?
Oh, I think we bought him lunch. Yeah.
There you go. There you go. All right. Just a real quick break here. The Being an Engineer podcast is powered by our company, Pipeline Design and Engineering, where we work with predominantly medical device engineering teams who need turnkey custom test fixtures or automated equipment to assemble, inspect, characterize, or perform verification or validation testing on their devices. And you can find us at testfixturedesign.com. Russ, tell me a little bit about the organization at Sisu. Like, what's your org chart look like? How have you structured the company? Anything that you've done that you feel like is innovative or interesting and has really helped, productivity and just a sense of culture at your company?
Sure. So we wanted to keep the org chart just as flat as possible. We like the idea, and some of it comes from National Instruments, where even the CEO didn't have an office. No one had an office. Just visually, everybody's kind of on an equal playing field. And I feel like that really helps facilitate collaboration. And it also helps with idea sharing, that, nobody's trying to win. We don't care where the idea comes from. It could come from anybody. We're just looking for the best idea. And so, like I said, we tried to keep it as flat as possible. When we hit about 30 employees, I would say, is when everything started to really break. And we realized, Russ and Marc, the two founders, they just cannot run this company by themselves. It's too big, and it's still a small company, but even that many people, the administration was just too much. And so we debated a lot on how we should fix that. And what we decided to do was to have a number of directors. And so these were folks that we didn't hire them from outside. They came from internal. We debated on what we called them. We decided to call them directors instead of managers. It just had a better, again, this idea of collaboration to it. We debated on, do we have engineer 1, engineer 2, entry level, staff level? And actually the debate on that still goes on. There's pluses and minuses to it. But what everybody kind of came out with was, the hard part was, we wanted people to feel like they were moving forward in an organization and have something they could point to, but we didn't want to have it look like one person was more important or smarter or whatever than another person. And so we actually just did the director level. So we really just have kind of those 3 different levels. There's me and Marc, and then our directors, and then the folks on the teams. So that's kind of how we did it. Again, pluses and minuses. As far as helping people to feel like they're moving forward, we identified a number of certifications that people can get. Agile certification for project management, or for programming certifications, or mechanical engineering, SolidWorks certifications. And so we really support and encourage people to gain those certifications. It's things that they can put on their resume. It's stuff we can talk about publicly and recognize people for. And then the other part of that, I think we have what we call Sisu lunch every Thursday. We get everybody together and provide lunch, and we use that as a time to recognize the effort that people have put forward. There was a study one time that looked at what motivates people, and I'll get it all wrong right now, but the bottom line of the study was that titles and different things, while they're okay, they don't motivate a lot, but recognition does. And so we decided to frequently recognize achievement and effort on specific projects, and that seems to go a long way to bringing people together.
I love that. You ever watch the show Whose Line Is It Anyway?
Yeah, it's been a while, but yep.
Yeah, they have the point system that means nothing, really.
Right.
we do the same thing at Pipeline, where we give each other points whenever someone does something noteworthy, and nobody keeps track of the points, and it might be 5 points or 5,000 points, but it's been a fun way to recognize someone for doing something good. And occasionally, if someone screws up, we'll give them negative points in kind of a tongue-in-cheek, joking sort of way. We're not really trying to penalize anyone, but it's been a fun system to use internally.
I like that. That's neat. I'm going to write that one down.
All right. Let's talk about the Pipe Dream project. This happened quite a while ago. It was probably 7, 8, 9 years ago, at least. Tell us, what is the Pipe Dream project? How did it get started? How did you have the idea to take that music animation and bring it into real life?
Yeah, so our very first project was the Nerf Dart project, which we've done a number of trade show demos or flashy demos like this. And the idea with each of these has been, let's take something that's in pop culture and let's mesh it together with whatever product the customer is trying to show off. So the pop culture thing, the robotics thing, that'll bring people in, and then we can really showcase the capabilities of their product. So our very first project was for National Instruments. They were selling these high-end servo motors. So it was a way to show them intercepting a Nerf Dart with high-speed vision. So it kind of used a bunch of their products just to show off and bring people in. An extremely popular demo. Well, Intel, some representatives from Intel were at that show. They saw that, and they started talking to us about doing a demo for them to show off their Intel Atom processor and all the different ways that you could use it in an industrial setting. And my goodness, we worked so hard on that proposal and just gave them all kinds of ideas. They loved the ideas, and then nothing happened. Month after month after month, nothing happened. And since we were so new at this, we thought, what in the world is going on? We thought they loved this. We thought things were going great. And then where are they? It's just shut off completely, and couldn't believe it. Now we realize that happens with every single project, especially if it's a big project. And so they kind of disappeared. We filled up our schedule. We had our schedule almost completely full. And then 9 months later, they called up and they said, hey, this is Intel. That project you want, we just got it funded and we're ready to roll. And we need it in 90 days. So it was...
No problem.
No problem. Yeah, so it was based on... There's a great company called Animusic. They do these computer-generated music videos, which usually have a big... machine, some kind of a machine that makes music. And this was one they did back in, I think, 2001. And there was this spoof going on that said that it was done by somebody at the University of Iowa with farm parts and pipes. And of course it wasn't true, but Mark and I had seen that years ago, and we thought, wow, what if somebody actually built this one day? And so when Intel came and said, how can you show off this processor? We said, what if we built this thing for real? And we use Intel Atom processors to run the various machines within it. And they loved the idea, pitched it, again, from concept to delivery. I mean, the craziest project. We worked, that's when we hired our first employee. We did 2 months of 80-hour weeks back to back. Oof. And when we loaded it in the truck to drive it out to San Francisco, it still wasn't working. And
no pressure.
No pressure. And Mark's wife, I think, was actually having a baby at the time, so she had her baby.
Oh my goodness.
She had her baby while I drove the truck out, and then he flew out and met me, and it was like, if you watch Top Gear, it was like a Top Gear race where they meet at the same place. And we pulled it out of the truck, put it together, did some tweaks, and literally by the grace of God, somehow it worked.
Wow.
Yeah, so we got there, pulled it out of the truck, and as I said, by the grace of God, it worked, and it was great. Intel was very excited. They told us later, they said, we didn't think there was any way that you could do it, and we said, yeah, we didn't think so either. But it worked, and although no other customers are coming to us saying, "Hey, can you make a machine that mimics a music video?" It's always been something we could point back to when customers ask us, "Can you really do our project?" We can point to that and say, "Well, we did that," and they go, "Oh yeah, you can definitely do my project." So it's been a great recruiting tool, a great way just to show proficiency in the industry. So.
And it's really not possible to communicate how challenging and how detailed and complex this machine is, this trade show demo is, just with words. So I encourage all of you out there, go to YouTube, type in Pipe Dream, Animusic, Sisu. That should bring it up, and watch this video. It's incredible. It is so cool.
Yeah, Intel did a video. If you do Intel Pipe Dream and find the video that was made by Intel, It probably has the best sound. It's probably the best video of it.
Great. Okay, great. All right, so let's talk about a project that your team did very recently. So we're still in the whole COVID area right now, and ventilators are in short supply and high demand. What has Sisu done recently to help on that front?
Yeah, so in mid-March, it's not, thankfully, it's not as big a deal right now. We've been able to, the curve has been flattened to where we're not overwhelming the system. But in mid-March, in Italy, there were people were running out of ventilators, and so the option that people had, their healthcare system was completely overwhelmed. If you had a very bad case of COVID-19, your choices were a ventilator if you were lucky, and if not, you got a morphine drip until you passed away. And it was just a horrible thing. And New York at the time was headed in that same direction, and they said that New York, well, we got a call from a guy that we've done business with before that's funded a number of our projects. And he said, hey, look what's happening in Italy. New York's projected to be in the same place in 2 to 3 weeks. And he sent us an article from 10 years ago about a mechanical ventilator that a team from MIT had concepted, and said, could we do something like this where we squeeze one of these manual resuscitation bags, like the ones you see on the ER shows? He said, could Sisu build something like that? And I said, absolutely. And he said, how long would it take? I said, I don't know. Let's find out. He said, we need it in, 2 to 3 weeks because they're going to be out. So that was the goal. We dropped everything. We worked around the clock. I think the record was, I think we hit the record of number of hours for somebody at Sisu. I think actually me and Mark tied the record at 96 hours for the most hours worked in a week. And it wasn't 1 week. It was week after week. So anyway, we ended up after 16 days later, we had 100 units on the table that were ready to...
16 days. Wow, that's days. Incredible.
It was unbelievable.
How did you move so fast?
So, we started out by, the news just did a story on us. And one of the things I said in the news was, when the guy called, he said, can you build a ventilator? And I said, absolutely. What's a ventilator? And we didn't know. We'd never, we've heard of them, but what does it even do? So the first thing was just to learn everything we could about it. So of course we went to YouTube, and we literally just watched a lot of YouTube videos, and then we started calling people, and we talked to maybe 20 different respiratory therapists, pulmonologists, anesthesiologists, critical care nurses, and just gathered information as quickly as we could. And then we just started buying stuff. We bought everything that we could think of that might be useful. And while design was going on, we were calling up shops, manufacturers, metal shops and everything, and saying, hey, we're going to build this thing. We need to get it done as quickly as possible because they're running out of ventilators in New York. Do you want to help? And everybody said, absolutely, we'll drop everything and make this happen. And so we would literally get parts designed that day, and they would build them overnight, and we would have them the next day, which usually, as many of you know, if you try to get custom parts, you're anywhere from 3 to 6 weeks out.
Yeah.
And folks would turn them overnight. We would get them in. We'd put it all together. It was just a beehive of activity. We called everybody back in. Everybody wore masks, but it was just kind of hey, we know this virus is out there, but we've got a job to do. Let's get this done. And we just had, we usually use a very precise project management system. We use Agile. That honestly all went completely out the window. And it was just people working on everything was done in parallel. Said, let's work on what are the designs that we could do for this. And said, okay, these top 3 are the best. Let's work on those all together. So if one fails, we can pick up the other one. And things would fail. They wouldn't quite work right. Parts wouldn't work. We just started buying motors like crazy. We got the PCB designed and sent out, had a microcontroller on it, switches, and a bunch of software. So we prototyped as quick as we could. When it came time to actually build the prototype, usually you'll build maybe 5 of something. If it's going to be a production piece of equipment, maybe you build 5 at first because it's not going to work. And talked to our, the guy who's funding all this and said, he said, "Where are you at?" And I said, "Well, we're about to order the first design." And this was maybe 13 days in, and he said, how many are you going to order? And I said, 5 to 10. He said, I want you to do 100. And so, that's just insanity, right? You never build 100 of a prototype because they're going to be wrong. And so we'd already ordered, I think, the circuit board one time, or did we? I can't remember, but we did. We ordered 100 of them, and they all came in. And of course, there were little issues here and there, but they worked. And it's, people stayed up all night long doing reworks on PCBs and putting it all together. And so they were ready. And New York came to within a day or two of running out of ventilators before things started to go back down. And it was a nail biter. And, we're very blessed we didn't have to use those. But we continue to work on them, and we've made another couple of revisions, and now we have orders for about 1,000 of them pending for local hospitals, and then the Army is looking at buying up to 10,000 of them, basically as an insurance policy in case we've got a second wave of this thing coming back. So we may sell a few thousand, we may sell none. We don't know. But
what an incredible story, though. What's the cost of that? Because I know some of the ventilators out there, the ones that have been used in the past, I think they're pretty expensive. $20,000 or so. What are yours costing?
Yeah, so the ventilators now range anywhere from $20,000 to $60,000 typically. The cost of materials on ours and the labor were just over $2,000. Now, of course, we put a lot of effort into the software. There's a number of teams that have done similar things. MIT came out with one, University of Minnesota, a lot of people trying to solve this problem. We took the route a little bit different. Instead of finding the cheapest way, some of them are saying we can do it for $500. We said, well, this thing's got to last for 800,000 cycles a month. So you may have a device that needs to do millions of cycles. Say, let's make it so it can do millions of cycles. So we use very industrial parts. And then as far as the software goes, many of these simpler ones are just made so they'll just push a specific volume of air, regardless of what the patient's doing, which is great if the patient is completely, paralyzed. But as they start to wake up, or if they start to breathe on their own, you don't want the ventilator just shoving air in there. So we put a lot of sensors and software into ours to make it so that it will detect the patient breathing and be able to respond to that and kind of help them along the way instead of just pushing that specific amount of volume. So and there's a reason. I think there's a lot of news stories that say, these usually cost $40,000. This organization did it for $1,000. I mean, this is a machine that keeps people alive and has to work no matter what. And there's a lot of regulations and a lot of technology and backups and everything. So there's a good reason they cost that much. But in an emergency, I think of ours as the donut tire in the trunk. You really don't want to use it, but if you have to, it's there.
What an incredible story. Regardless if you sell 100 or 1,000 or 100,000, you always have that accomplishment to look back at, and I'm sure that's got to feel very fulfilling, very satisfying.
Well, the team did a great job. It would be completely impossible unless you had people that were just driven to do the right thing and wanted to help out in an emergency. You can't pay people to work like that.
Wow, that's a powerful statement. You can't pay people to work like that. There has to be some kind of higher level purpose, to motivate a person to work like that. Russ, last question here. What are one or two of the biggest challenges that you face at work, daily, weekly, monthly?
Oh, the biggest challenges, I think, of course, like everybody has, feeding the machine, right? How do we market and sell and bring in the business that we need? And are we, I think it's something that every business owner, constantly worries about. If they're not, I need to learn their secret. Probably the other thing is just what do we do? What do we focus on? And maybe even more difficult, what do we not focus on? What do we cut out? What's something that we love to do that just does not bring in business the way it needs to? And do we have the courage to cut it out? And that's honestly, that's a hard one for me. I think a lot of business owners And engineers love the fact that, can you do that? Yeah, we can do it. How about that? Yeah, we can do that too. And instead of saying that, say, yeah, we can, but should we? Maybe we shouldn't do that.
Yeah, that's a great way to look at it. Yeah. Russ, how can people get a hold of you or Sisu? They've got a project, they want to talk about it. What's the best way for people to get a hold of you?
Yeah, so just go to sisu.us, and there's a big button on there to schedule a free consultation, and all of our contact info's on there as well. So you can send an email to our email box, and our phone number's on there. So yeah, we'd love to hear from anybody.
Great. Thank you so much, Russ, for spending some time and sharing your stories. Honestly, I've talked to a lot of really interesting engineers that have shared some great insights. I don't think I've talked to anyone that has shared as many really just compelling stories like you have. The COVID ventilator, getting that done so quickly. I feel like someone should make a movie about Sisu, and people would watch it. If you film it, they will come for sure.
They should use our cinema camera for it, huh?
Absolutely. See, this is a win-win. Yeah, you get some free marketing in the process.
Great. You're very kind, and we really appreciate it. And just tell everybody, we have learned an incredible amount from Aaron, and you guys have been a great supplier to us as well, helping us on projects that we didn't have enough resources for, and a number of the projects that are on this, Pipeline has been instrumental in helping on, including, I believe, the Intel one, right?
That's right. We played a very small part in that way back in the day. Yep. Yeah. Yeah. Well, thank you for saying that. I'll get you your kickback after the show.
All right. You know where to send it. Thanks,
Russ,
Aaron.
thanks again. This was great.
Yep. Thank you.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please leave us a positive review. It really helps other people find the show. To learn how your engineering team can leverage our team's expertise in developing turnkey custom test fixtures, automated equipment, and product design, visit us at testfixturedesign.com. Thanks for listening.